We can start now. Welcome and thank you for joining us here on stream 2 at DSC Europe 2025. My name is Alexander and I'll be your host today for these exciting sessions. Today we're kicking it off with Maya Malamud, AI consultant and data scientist. Her session is titled Building Trustworthy AI GenAI Systems, Monitoring, Evaluation, and Feedback Loops. Maya, the stage is yours.
Thank you. Welcome, everyone. It's a shame I can't hear you as well, but I'll be happy to communicate with you via the chat. So feel free to write, and I will be looking at it as well. So this is our workshop today, Trustworthy AI. I will talk about the motivation. We have the full code here. You will also send the notebook. It's in Colab, so that we will not face any issues with dependencies and such. And what we will do today is talk about how we can trust the AI, right? Because everyone is talking about AI. AI is something great to develop. We want AI in our organization as soon as possible, if possible, yeah? And what happens is that we have trust issues, right? Because even if someone doesn't know AI at all, and please, if you can write in the chat, maybe your name and your background a little bit, so I can talk to you as participants. So even if we use ChatGPT, Claude, Gemini for our own personal use, not industrial one, we see that sometimes it hallucinates, right? It gives us complete bullshit, right? Sometimes it's not really what we were asking for. It's a very good answer, but for another question, right? So when we try to do this same thing as a system, a GenAI system for an organization, for clients, for people that we really want to trust them to trust us, and that will get all the good answers that they're looking for, but we want to use AI for that, how can we combine the two things, right? So you are here in this workshop. I'm sure you know why this is so important. I will say another thing, that a lot of AI projects go to POC, right? I'm a consultant, I'm employed for POCs frequently. And what happens is that in many organizations, they're not looking ahead how they will go to production with that, how they will be able to do something that they can trust with their clients outside of the network. So what I advise is that before starting any of the AI, anything that you want to do, you need to build it in a manner that you will trust, that you will be able to say, I give good answers. How do you know that they're good, right? We will start from a small example, and then we'll go from the small one to something more robust that we can do in a scale, okay? So in the notebook that you have, it's a Colab notebook, okay? What you should do is that you should do File, save a copy in Drive, okay? And then you have a copy of yours that is not this one that I am working on, okay? And then you change its name. You give it a name with your name, okay? So that you know it's yours, or the date, or whatever name you want. And then you can run it and work with it. So a small abstract of what we're gonna do. We start with some imports and setup that is very easy to run, right? So what I put here is a general one that everyone can do. Sometimes you won't need anything. If it's already installed, it's okay, you don't need it, but let's go over what we're working with today. So we'll be working in Python, of course. This is the main language today for AI. We'll work with LangChain. Okay, it's a very good platform we work with. We have some packages of LangChain, different ones that we need. They just upgraded to version 1 not long ago, and some things are a bit tricky about this. So you have here everything that you need to work correctly today. We'll work with Ragas. Ragas will be the evaluation package that we will use to do evaluation on a scale. Okay, of course, we'll work with OpenAI for all the LLM generation and questions that we want to do. And we'll work also with LangFuse for the monitoring. Okay, I will show you already what is LangFuse, how it looks like. So this is my LangFuse. See, I have my name. I created a project that will be a hobby for this workshop. And what you can see is if I go to my view of Maya, I go to project. Okay, this is what I did for this workshop in the last few days, just to show you. So the total cost, and I ran it many times, this notebook in very different versions, not even $1. Okay, so your OpenAI free subscription should be more than enough. It's about $18 to $20 that you get when you subscribe for the first time. And I will be using the very cheap model for this workshop, GPT 3.5 Turbo. Okay, it's very cheap, which is important. It's very fast that we want. And also it's good enough for what we will be doing today. And sometimes even in your organization, it's not that bad a model. But you have for not too much more to pay, you have some better models. So if you do it internally in your organization, you can consider other models. We'll go with the cheap one today. So what LangFuse is doing is that everything that I'm using OpenAI for, which is, you will see in the code soon, but it's called traces. Okay, I integrated into the code the LangFuse caller, okay, handler and caller, that what it does is it registers everything that we will do using OpenAI for our code. So this is in general, what you can see is that I'm checking for many things. For example, confidence, it's part of my prompt. I'm using Ragas for some evaluations criteria that you can see what is the average score that I got for this model. Is it good or not? We'll find out. And what else you can do? You can go to tracing. Okay, see exactly all the things that I called the LLM for. I call it both for the RAG and for the Ragas. It's two different things. We will see it. So for example, if I go to one that is RAG evaluation, I click on it and I can see everything that is corresponding to it. Okay, so for example, you see the answer that I got, the confidence, the patient, what was the question that I asked. Okay, soon you will see it in the code. And all the score that I got for it. Okay, there's also a log view, whatever you need, and you can add more columns to see when you look at the traces. Okay, here you can add many more columns that you want to see and monitor your work and what you do. Okay, what is important is you get the prompt. Okay, I clicked on it. You get the prompt that I sent. This is the full prompt that we will be sending. I spent some time working on it. As you know, prompt engineering is something not to be dismissed. It should be as best as you can to get good answers. So it's a bit long, okay? It's not just one line or two. And let's look at it a little bit. So we have the context, what we want the LLM to know about the world, the general knowledge. We have a question that we want to ask about this knowledge. We give the LLM some instructions, okay? We are also saying you are answering a question based strictly on the provided context. So this is very important to say, and we don't want him to use any other information that he was trained on. We give it the instructions, what to do, why to do it, how is the score, a confidence scoring criteria goes, what is 1, what is 0, and what is in the middle. We give it some examples, okay? I gave it some examples here to show 2 different things that I wanted him to learn. Of course, at first I ran a very simple prompt, and from the answers that I got, I saw what is needed to make better in the prompt. Okay, there is some general knowledge of how to construct prompts, but the examples that we give it could vary depending on our subject and what is coming out as the first results. So this is something you will monitor. Okay, if you will change the prompt, that is part of what you can do in this notebook, you will see how the results change for you. And of course, we need to provide your response in the following format. Okay, we need to provide 3 things. What is the answer? A full sentence answer. What is the reasoning? Why is this answer? Why did you answer this? And also the confidence of how sure you are of your response. So a number between 0 and 1. Okay. And this is the answer, reasoning, and confidence that we got from the LLM. Okay. So let's go to the code. And after some imports and setups, what you have here in the second cell is that you need to enter your own open API key, LangFuse key, which is one public and one secret that you get. Okay, so I haven't entered them here in the codes because I wanted you to be able to copy the notebook. But once you have the notebook with your name and you're sure nobody else has access to it, you can change these lines, just instead of just get the input from the user of the notebook, just hard code it here, okay? So we call LangFuse, so we know that it works. We initialize the client, etc. We do all the imports, okay? We have some option of vector store. I will talk about it soon, and now we'll talk about RAG. And we have the LangChain, LangFuse, Ragas, normal Python imports, etc. This is for the logging and warnings that I didn't want them to be printed in the notebook, but you can just remove it if you want to see all the warnings. And let's talk about why we're here. So I said a little bit about that we need to trust our AI. But what is AI? We have the LLM, right? We start with the basic LLM, and we can chat with it, for example. We can ask it questions. So what are its limitations? Well, for one, it struggles with niche knowledge. For example, in this notebook, I will show you a very simple case of a healthcare data set with specific patients. So today, LLMs are a bit more trained on medical knowledge, but still, when it's a very specific niche, they struggle. They're not trained on enough data for it. Many times they have hallucinations, right? When they say something that is not really correct, just to say something, okay? So many times to prevent hallucinations in the prompt, you will say, if you don't know the answer, just say you don't know. Okay, we'll see it here. Their knowledge base is static, right? Because if they were trained even last month and something new came up in the AI world and I will ask my favorite LLM about it, he won't know, right? They have the option of searching the web, but it's not always very good results, okay? And one of the important things that we have as a limitation of the LLM as we see it, that it's a black box reasoning. Okay, so it's very hard for users to trust the output of the LLM based on the black box. We don't know why it's decided. We don't know why it says the answer is patient B. So what I did in the prompt is that I asked for reasoning, okay? But we don't really know what went on since the LLM got my question up to the answer and then the reasoning that he gave. So it's somewhat of a reasoning. We know it's not the full picture. We still need to be checking the results to see if the LLM performed as we think he should. Okay? Then came RAG. Okay? RAG, Retrieval Augmented Generation. We'll see the structure. What it does is that it addresses the LLM limitations. Okay? It can access real-time data, private data, or domain-specific data. For example, if you're an organization that doesn't want your data to be exposed to the outside world, then having an internal RAG is the answer, because you can get some answers from the LLM from outside and then add to it the reasoning of RAG and all the knowledge that we can give, the internal organization knowledge. We give it only to the internal RAG, and the outside LLM can't see it and will not be exposed to it. Okay? So, how does the RAG works? The RAG prompt in general, we tell him who he is, his job description, right? It helps, the prompt. Then we give him the external knowledge. For example, our organization's Excels, PDFs, instruction manuals, any big tables that we have of anything, right? Pictures, whatever data you want. Then we add a query about this data, right? For example, if I have a manual of how to fix the train's engine, right? It's my private knowledge. I don't want it to go outside of the organization, but I want a junior mechanic to be able to read this very, very long PDF and ask it questions, right? It doesn't usually know everything by heart. So instead of starting to read the manual and looking for anything he wants there, we can have the RAG look for the answer for him. Okay? And it takes all of these things together and generates an answer for the user. How does it work in the backend? So we have retrieval, augmentation, generation. Okay, these are the general phases. What happens is that we have the most important thing for RAG is the knowledge base that we have behind the stage. So we have a knowledge base. For example, the instruction manual. It's a very, very long document, or many, let's say 500 long documents. What we do is that we give them a vector representation. It's just a very long list of numbers that represent the knowledge in this manual, okay? So all of these documents are going through a process so they can be stored in a vector database. This is a process I will not be talking about today, okay? Then we get the user query, okay? And we want to give the LLM in this part the relevant parts of the instruction manual to be looked at by the LLM. So we want to take not just 500 very long documents and just shove it to the LLM because it's very long context. And we know that LLMs today, as best as they improve, they still struggle with very large context, right? So we want this context to be relevant. And what we have is some retrieval methods, right? This part, which I will, again, not be talking about today. But there are ways to optimize this so that we will get only the relevant parts of the very long documents passed forward to the LLM. So we get the relevant documents via a retriever. Okay, we add the user's query and we send this to the LLM together. And what we get from the LLM is a generation of an answer based on both. Okay, for example, if the user describes some symptoms and it connects to the flu strain announced yesterday in the news media, then the LLM can say, based on latest evidence, in summary, for you, it sounds not very likely that you caught this flu. Okay, so the LLM can combine the query of the personal user with the internal knowledge of the organization together and give a connected response, having looked at both together. So this is in general what is RAG. So what we will do today, we'll use very, very small data with only 5 documents, very short ones. This is for cost reasons and speed reasons. I want it to work very fast for you when you work on it. And also we want to be able to read it and apply some human logic to see that for me to convince you that what we're doing here is accurate, okay? And it makes sense. I want you to see the actual text. Of course, you can put, instead of docs, you can put any text you like. Okay, so for example, we have 5 documents, each talking about a different patient from A to E. We have some knowledge about each. This knowledge is not structured. It's not structured. It has some explanations and descriptions. It's a bit different for every patient. Some we get their age in some format, some we get it in another format, etc. Okay? So we start with very simple code. We'll go and build upon it. And at the end of the notebook, we get the full code with everything included, right? So you can just run the whole notebook if you want. But I want to go over it with you. So first, what we do is we create for these docs embeddings. Embeddings is the vector representation of the sentences, okay? And we use files as a vector store to store these vectors. This knowledge, now in numbers, is stored for us, okay? So for example, if we want to print the embeddings, right, let's see it. We can see that it's an OpenAI embedding, just an object. It doesn't tell us much, right? But what we can do is we can try to print what is the retriever and see that it's a vector store retriever with FICE and OpenAI embeddings, etc., etc. Okay? So we have these objects and we create a retriever using it. Okay? We won't talk about how we do that today. It just works for us. That's great. So we go to the prompt. It's exactly the same prompt I showed you in LangFuse. Okay? And I give also the format of how this prompt will be. It will get the context, it will get the question, the instructions, explanations, examples, and structure for the response. Okay? Then we configure the LangFuse handler, okay? The one that will be used here for us to record all of what we will do here within LangFuse so we can use this platform. So this is our model, very cheap one, as I said. The temperature is 0. I don't want the model to hallucinate. I want it to be based exactly on the text he gets. And using lang chains, we create a chain. We have a Q&A chain. Okay, we will give a question, we want an answer. We give it the prompt and the definition of the LLM. So we have the retrieval chain ready. Something else that we need, you have some code here for parse LLM output. The output will be given as an AI message object from LangChain, and we want it to be able to use in a better way in Python. So this function will return a dictionary with answer, confidence, and reasoning. Okay? So you can look at this if you want later. Let's go to the interesting part. We start with some examples. So I wrote 3 queries, okay, asking about general things that happen to patients in general. And I think these answers are within our docs. And I want to see if the LLM will be able to find them. Okay, for example, which patient presents with symptoms most consistent with a possible cardiac issue? Okay, so let's go back to the docs and see who we have with a cardiac issue. For example, patient B presents with chest pain. Okay, let's see. Maybe the LLM will give us some more ideas. Okay, so we have these queries, 3 questions in general, and I want to store all the results in examples. So I go over the queries, right, one by one. And what happens is I invoke the retriever, right? I send it the question and I want to get the retriever. What it gives me is the relevant documents. Now I haven't said what should be retrieved, so it just goes by default. I get some documents from my original documents, just the documents as they are. Okay, I don't do anything with them. It's a very small data. We don't go into this. And I put it in the format of context. Okay, this is the context that I will send the Q&A chain. I want to invoke the Q&A chain. If you remember, it gets the prompt and the LLM, and I give it the context and the input, the question, the query. And also it has the Langfuse listening and monitoring for everything. Okay? I get a raw result. I use the function parseLLM output to get the result in the format that I want it. I store the result and I print everything. Okay, I append it to examples, right? And let's see what was returned from the LLM. How did our AI work? Was it good or not? Let's see. So the question was, which patient presents with symptoms most consistent with a possible cardiac issue? Let's skip the context because these are simply the documents. And we get the answer, patient B, age 45, presents with chest pain, etc. The AI is confident 1. It means the highest score for confidence. And the reasoning it gives, the combination of chest pain, non-specific ECG changes, and normal, etc., it's a very human response that we would expect from a professional. So, for example, in the medical world, what can happen is that this reasoning will go into some chatbot for the doctor. Let's say there's a doctor. She sits in her office. She gets this patient. She has some data and she's thinking. And she wants the LLM to help her think. So she gets all the docs that she can about this patient or about these patients, right? And she adds a query. She will get an answer. She will get the confidence of how much the LLM trusts its own answer and a reasoning for that. So the reasoning can help see if this is something that she can trust. It's a first step, right? So we get this for all the queries, right? And the summary, 3 questions evaluated, all of them with confidence 1 as the answer. So the reason that all of them are with confidence 1 is that I asked very simple queries, right? I asked queries that I know will have the answer in the docs. So that makes sense. They found it. Okay, that's good. But what now? I want to check for other things. I want to check for no hallucinations, correct? So let's see if we can find some misleading queries. I wrote 5 queries here, right? That do not have the answer in the docs. or it's not something that is easily explained. For example, what was patient B's troponin level 3 days ago? So in general, troponin level, it's there, but we don't have it from 3 days ago. We don't know if it was 3 days ago, right? So let's use the same code for these misleading queries. What we get, for example, here, second. So the answer will be patient B's troponin level 3 days ago was normal, okay? Because in the docs it said troponin is normal, but it didn't say when. And here we get confidence 1. So this is a problem, right? Because we know it's not the correct answer, even though the LLM's reasoning is very good. So that's not something we will say, okay, let's continue with it. We won't go to production with that. We won't go to our client with that. So first, hooray to us for checking, right? Then what we'll do next is that we'll try something else. Please write in the chat, what do you think we should try? What is the next step you think should be? What else would you do in order for yourself to be able to trust this AI? Okay, so I still can't see any answers. Okay, so I'll continue. If you have some ideas, please write them down. I can also say them out loud without stating your name if you want. Okay. So we get this for all of the questions that we get. Oh, we have some question in the chat. We can ask the part of the context to quote, right? Very good. It's a very good idea. Okay. So we will do something a bit similar for that. Okay. That's what this idea about quoting the part of the context that is relevant. We will see it later in Ragas metric, okay? And also what can be done is that in the retrieval part, as I told you, it's a whole profession of how to retrieve the relevant docs out of many, many docs. There are questions about that, right? You can measure okay. You can measure how good is this context and how relevant it is for the question, right? And that will give you a higher rank when retrieving. There is a whole method of ranking the retrieved parts in order for the retriever to give you the relevant context. Okay, so that's a very good approach. What is written in the chat is that if somebody wants to speak, to answer the question, no problem. You can raise your hand and it will be enabled. Okay. Okay. So let's continue. We see the results for the misleading queries. So we have most of them saying confidence 1. And we know that for these queries, the question can't be answered with the docs. So that's a problem, right? That's not a good result. This is something that I will want you later to try and change manually, right? Can you do something to the prompt or the query so that in a way, this will get the correct answer, the misleading queries. So we know that we can't really change the queries of the users. Our only part that we can control after going to production is the prompt. So maybe you will try to work something out with the prompt. We see here that one got a confidence of 0.6. So maybe in the prompt, adjusting the confidence explanations of what number to give. Okay. Let's see. So total of 5 questions evaluated, the misleading queries, and the average confidence 0.8. 4 of them gave a confidence of 1. Okay. So let's sum up until here what we have, our data, right? So we have the question, we have for each the context retrieved, we have the LLM response, confidence, and reasoning for each, right? And the three first, we know that one is okay, but here we know that one is not okay, right? But if we go to production in scale, how can we know that one is good, one isn't good, right? Because let's say that we adjust for all these 8 queries. Let's say that we adjust for 50 queries. Is this confidence enough? What do you think? If we get a good confidence that is correct for 50 queries, correct queries, misleading queries, we get a good mix, and we get the correct confidence for 50 queries. What do you think? Do you feel safe enough to go to production with that? Okay, nobody's answering. So the answer is no, right? Because we can measure more things, right? Like when LLM started, maybe you would say yes, but you would get so many hallucinations that the financial damage done, there are some very funny examples in the web, the financial damage done with these kind of systems going to production, going live for customers, when hallucinating, when doing things they shouldn't, was a very great damage. And many systems were shut down in their first days on air. Okay, so that's not good enough. We have to dig deeper. We have to do something that will tell us that we can trust this system. Okay, you will have some time later to try and adjust the prompt and see if this gives better answers. Okay, if you have already some ideas on how to adjust the prompts, you can write it on chat, even privately to me or to everyone, and we can try it together later. Okay, let's continue. I said, okay, let's add a column, right? If we think tabular data, which is the classic data science that we had in the past and we use today as well, we say, let's add a column, right? A feature that will help us do something. So I added a column of patient. I extract the patient, which is the patient that is talked about. I first try to extract it from response, okay? Which is the response that the LLM is talking about which patient, right? And then if it's not there, we can try to get it from the question, okay? Because if the reason that I do it in this order is because if the query is general, saying, who do you think has more chance of a heart attack? So the query doesn't contain the patient. It's more relevant that the response will contain. So I get the patient, right? How can it help me measure if I'm doing a good job? If the patient was always included in the question, then I could check, is the patient in the question the same patient as the one in the answer? Okay, so it is, but we know that not all queries have that, and also that not all queries are talking about a specific patient. Maybe just a general question like, when was the last time anyone had the flu? We don't care who it was. We just want to know the time, right? So this is a step we can try, okay? I want to introduce RAGAS. It's a RAG evaluation package, okay? There are a few more, but it's a very good one. And I want to talk to you about 4 metrics that we have in this package that are the ones considered the more basic and straightforward. There are many more, of course, but if you implement these 4, then I can trust your AI, at least in the basic manner. Okay, let's see what it's about. We have 4 parts of the data, right? We have the query, okay, or the question given by the user. We have the context that is retrieved from the docs, right? So maybe we can improve the context, improving the retrieval. That's one way to improve the context, but today we look at other things. We have the LLM response, right? The answer. And something else that we have. We can, for 8 options, for 50 options, for 5,000 options, we can write what is the ground truth answer. What does that mean? It means that we will see the example for our queries, but it means that we have something that can't be disputed. This is the truth, right? This is the correct answer relevant to us. And we want the ground truth. What happens is that it's not adjusted to a specific query. Okay, it's something more general that we write because we won't know in advance all the possible queries. So we will look at it soon. But the measurements, the metrics, the RAGAS metrics that we can try and measure our results with are the following. So I'll go by the order of how popular they are. So the first one is faithfulness. Okay, I give you all the explanations here. It measures if all the claims made in the answer, everything that is said here in the response, can be inferred from the given context. So it just looks at these two together. Are there hallucinations? Did the LLM go and say some things that are not here in the context retrieved? Okay, so we want a high faithfulness. Next, answer or response relevancy. Measures how relevant the generated answer is to the query. So the answer, right? With the query, answer relevancy. How it's calculated, you have an additional explanation for who's curious about it. It's the mean cosine similarity, right? Cosine similarity, it's a way to measure distance between two vectors. So if every sentence or every paragraph is represented as a vector, then you have an option to compare between the two. So you can use the cosine similarity for the distance between these two vectors, and you measure it between the original question, right, the query, to several artificial questions generated based on the response. So let's hold pause on this one. Let's explain it a little bit, and you will understand why applying RAGAS in your code is more expensive with OpenAI than just using the normal LLM, okay? What happens is that you see the response, right? This is a general answer. And what RAGAS does is that it invents, right? It creates, generates a few possible questions that were the trigger for this answer without knowing the true query, the true question, right? So if I say, my name is Maya, you can think that maybe the question was, what is your name, right? Or a few more options if the sentence is more complicated. So we check how the real answer, how close it is with the vector distance, the cosine similarity, to several artificial questions generated. Okay, not to the actual answer and query, but between the query and possible generated queries. Okay, so this is a generation thing. It takes some cost from the AI. So that was answer relevancy, and it's a very good measurement. The third one will be context precision. Okay, It measures the proportion of relevant docs in the retrieved context. So we look at the context and we say, how many of the documents retrieved, because for a large documents, right, for a large let's say that we have a very large pool of data, right, 500 very long documents, and it can be 5,000 or more. We have all the data, right? And some of it will be retrieved. This retrieved part is the context, okay? So what we ask is, are the ones retrieved relevant to the docs, right? How many of the relevant docs are in the retrieved context? Okay, for example, for that we have to look at all the docs. Okay, what we do is we measure how well we did with the retrieval. Okay, and the fourth one is the context recall. We measure how many of the relevant documents were successfully retrieved. We don't want to miss important results. Okay, so precision and recall, such as in normal machine learning that we all know and love. So these four measurements, these four metrics, right? We need AI to apply them, right? So it has some cost. But what it can do is that every one of them gives us a numerical value of how trustworthy is our system, right? So these are very important. Let's look at our ground truth. So the ground truth is the patient references. It may be the doctor's notes of every patient. So we have one for each patient, and it has some summary about all of its things, knowledge, documents, checkups, EHR, whatever, comorbidities, okay? Current medications, what he reports, okay? Remember patient A has type 2 diabetes and hypertension. Current medications include metformin and lisinopril. Reports fatigue and elevated HbA1c. I'll give you some medical knowledge. Elevated HbA1c is a measure of not doing well, maintaining balanced his diabetes. Okay? So for a doctor, this makes sense. For a professional, for someone who understands that knowledge. But let's say that we're not doctors. We only has this, and we want the AI to help us. Okay? So we give to each patient in the data the references. We save this, right? CSV, JSON, I want everything saved in the process because if the process dies, at least we have everything kept, right? In Colab, if you're gone for too long from your PC, then it restarts, okay? You have to run everything again. And we prepare what is called a Hugging Face dataset to introduce to RAGAS, okay? It's just a format, a Python format, okay, that is needed. And we introduce the metrics, the ones we talked about: faithfulness, response relevancy, context precision, and context recall. And we just do this evaluation, dataset metrics LLM. Okay, this is, I build it part by part, and we will see it all together soon. So what we get is that we run 32 metrics. Why 32? Can anyone answer? In the chat or raise your hand. we only have 4 metrics. Okay, I will continue. What happens is that we have 4 metrics, but we had 8 queries. So for each query, we do all of these metrics again. And we have the average measurements, metrics, results, okay? So what we do is that we add this to the data frame that we save everything, okay? So we have the 4 metrics here, okay? And we put it together with the original data frame that we used. So we have in general question, context, response, the confidence of the LLM, which we said should be worked on, the reasoning it gave, right? The patient that we say that it's maybe a good column, maybe not, okay? Then we have the ground truth, okay, the reference about this patient, because it knows which patient to bring only by this column that we said we're not sure it's that good, right? Showing you the complexity of building this system in real life. These are things that you should consider, right? Because it's not a straightforward work. And then if we have this ground truth and everything else, we can calculate these 4 measurements for each query. Okay, so in the data frame, we will have 8 lines from 0 to 7, 8 queries asked. That we know the first 3 should get a good results, right? So we see that the results here are pretty high. That's good. Okay, but then we look at the 5 on the bottom of the table that are the misleading queries, if you remember. So we look at them and we see, okay, the faithfulness here is 0. That's good. So something is working, right? If one of these 4 is a very low score, that raises a question mark. I can go to this data specifically and see what happened, right? And not trust only this confidence of 1. So this is good. I see that here it's also 0 and 0, and here it's 0.5. I'm not sure if I trust it or not. We'll have to check. For query in index 4, we have a very high faithfulness, but very low answer relevancy. Okay? So the answer really is that the history is not provided, right? So we're not sure that the very low metric of answer relevancy is relevant to us, right? Because if the answer was it's not provided, and we know that it was a misleading query, right? But what we can do is that we can look at these numbers in general and create a system that we combine all of them and we make some decisions, right? If this is that, check this. If this is the metric, check that, right? And for the first 3 queries, which we know were answered correctly because they had the right documents, and if it has just right, it's a simple question, and we have the answer in the doc exactly, then the LLM won't struggle. It will most of the time give a good answer. So we see that these metrics are very high. Okay, so maybe all 4 that are high we can trust. Maybe that's an indication for our data. We would have to see more queries and more context to make that assumption, okay? This is a very small data set for us to introduce the subject. So now for the putting it all together part, okay? Then you will have some time to work with me on improving it. So I put all the queries together. It's all the 8 together, not divided into 2. And there are some helper functions. One is the extract patient. Okay, I'm looking at some text and taking out the patient, what I did manually before with regex, regular expressions. Here it's in a function. And the get ground truth from question, answer, and context. Okay? Now, this is the Langfuse. I introduced it in the beginning, right? So let's remember what we can see, and we will record everything in Langfuse, right? So I'm showing it again. We can see the prompt that we used. We can see for this LLM quest, we can see the latency, the total cost for it. This is the input tokens and the output tokens, okay, which the cost is defined by. There is a different cost for output and input, as you should know, okay? And we can see all the traces. If I run it again now, this notebook, I will have new lines here, okay? And you can also filter. For example, I want only the RAG evaluation, and I have it, okay? So, for example, this is the one where we had, let's look at it. Let's look at here. So the patient was C, right? And the question was, what is patient C's smoking history? The confidence was 1, but we know that the answer was that the data is not provided, okay? So these are things that we can see here, right? We have some metadata. I'll say a word about it. Working in RAG, not in a workshop zone, working really in RAG, you really need to consider working with your metadata. Okay, what does it mean? For example, if I have a very, very long document, metadata can be the name of the document, when was it published, right? How many pages does it have? I can divide this very large document into chapters, right? If it's already divided into chapters, then every chapter can be a doc. Then the metadata will contain the name of the chapter. And if it's a certain section of a page, the doc, then I can have in the metadata also the title that I have, right? And what is written in bold in that page. And in general, improving RAG, well, you have to compare it with the cost of doing it, but putting all of your data into a specific structure in the vector store is the main part where you can influence. Okay, so I have some workshops about that as well. If you'll be interested, talk to me. Okay, so what we do is that we will do everything now. We configure the LLM and embeddings for RAGAS. Okay, to work with RAGAS in general, we need to send it the LLM that we want to use and a text embedding model, okay, how the vector is created. And we do all the configurations. So then we go about all the queries. We have 8 queries, right? And the full process that we went through, right? We retrieve the docs, which is a part we can improve. We define the trace, okay, for us to see in Langfuse later. Okay, if you remember, we have the page of tracing. And we go to the QA chain, right? We invoke it, we get a result, we parse it, we take everything out of it, we get the ground truth after we have the answer, and we try to go to evaluation, okay? And evaluation, I wrote this code a bit more detailed, so you can use later for your own projects at work, okay? It has some debugging installed, right? Because many things can happen in a code, many things can go wrong, so at least some of them are covered here for you, okay? So it's a more detailed code. And we have the metrics, right? And we say which LLM to use for these metrics. If you remember, every metric in RAGAS is using an LLM to create the comparison and to give a score, right? So we complete this evaluation and we sum up the results, okay? We log to Langfuse everything, okay? In the process, we have a flash Langfuse. This is to make sure that everything went from our internal memory to Langfuse. And some debugging as well. And we have the results, okay? Let's look at them. For example, the first query, which patient presents with symptoms most consistent with possible cardiac issue? So that's a no-brainer. We had the correct answer before as well. It's patient B, confidence 1. Okay. We could have printed here the RAGAS evaluation for that as well, but we will see it in a summary at the end. So, for the question, what is patient C's smoking history? The answer is patient C's smoking history is not provided in the context, and we are very sure of it, confidence 1. Okay, and the reasoning is that it doesn't mention it. So maybe that's correct, right? We expect it to be correct because it was a misleading query. What else? Okay. So if you remember, we have 4 metrics. Okay, and this is the summary for all the results. We see that the faithfulness is pretty high here, right? It's a bit different because we used now a different LLM a little bit for the RAGAS. And we see that the first 3 queries have very high notes here. The third one doesn't have a good context precision, right? So all of these things are things that should be checked manually, okay? Saying that it's valid, it's for the debugging, okay? And you have all the resumes here. So what we will be doing, now we have some 20 minutes or so. What I want you to do is think about every part of the process. We can do it together. You can raise your hand and talk, and I will implement, or write me in the chat. And we can check some improvement options that you think about. What can be improved here? But the most important thing that I want you to take from this workshop is that it can be possible to trust your AI, at least in some manner. You can measure, right? You can measure what good answer, right? And good is defined in at least 4 metrics here. What is a good answer? And if you have 500 queries, you can do it manually, right? What if you have 5,000 or 50,000 or 50,000 a day? Okay. So I will give some more tips soon. I want you to create trustworthy AI, right? The most important thing I want you to take from here, even if you don't implement RAGAS or Langfuse at all, what I want you to remember is that you can measure how good is your AI, and therefore you can trust it a little bit more. And what you can do is think about all of these things that I talked about today from day 0, before you start coding, before you start your business plan. Think about what is your objective, what is the KPI, what is important for the client, what is important for you. How do you consider trust? Okay, there are many more metrics that can be adopted, and implementing them in code is doable, right? As you can see in this notebook, it's not a big deal. And I want you to be able to do that, to say, okay, AI hallucinates, but I can control it. I can control it even in scale. And that's a very important takeout from today. Okay, here is my LinkedIn. invite you to connect with me, and you can be able to ask anything in the future if you want about Trustworthy AI. And what I want us to do now is to think about options for improvements, okay? What else I wanted to tell you? I talked to you about options to improve the retrieval, right? I talked to you about working with metadata, and also there are more options for RAGAS metrics, okay? If your document is very large and you want to separate it into something in parts, right, in different parts to be each document limited context, this is called is chunking, okay? In RAG, we have the chunking methods. There are many methods, okay? When I do a workshop about it, I mentioned 7. There are many more. And the thing is that you want to think about how to split your long data into things that will make sense when retrieving them, okay? When you get them in here as the context for the LLM, what is the correct context that you want for the answer to be relevant, to be correct, right? To be whatever you want it to be, okay? So, who wants to think together about some options? What can we improve? We are today in the manual area of improvements. It can be something about maybe another query that you want to check, that you think can really impact the results that we will get, that it will discover some hidden truth about our data. It's very important to think of good queries, right? I'll say that the LLM can think of very good queries for us, but if we do not apply expert knowledge in this part, we might lose the rare cases, okay? So we can improve here. We can give more queries, okay? We can change the prompt, and there are many ways to do that, right? Okay, so here we have a suggestion in the chat. How can we adjust model temperature to get the best performance while preventing hallucination? So in general, I mentioned it before, the temperature that we send, let me look for it. It's hidden here, temperature. Temp, maybe. So the temp, not every temp. Well, it was when we called the LLM for the first time, right? We adjusted the temperature. What we saw was that in general here, temperature 0, it means that we want it to not be creative. This means that if it's not explicitly written, don't say it is, okay, in general. Temperature 1 means that it should be very creative. For example, if you're generating images for a publicity and you want to go wild on what you'll see, then higher temperature is better, right? But if we're talking about professional documents where the accuracy is very important, then temperature 0 is usually recommended. Did I answer the question? Was that what you meant? Okay. Any more questions are welcome. Sure. Thank you. Okay. So I want you to think about additional queries we can try, right? I want you to think about enhancements to the prompt that we can do, right? For example, let's see. Let's look at it. I have the prompt here in front of me. Okay. And the thing is, we have the confidence, right? We have the confidence And I gave it some examples. For example, I gave when it should return 1 and when it should return 0, 6. But I didn't give an example of when it should return 0. Can you think of something that we want to give an example to the prompt? An example of where it will return 0. A question regarding a different patient. Okay. That's an option, but what happens is that if it's about a different patient, then normally the context retrieved will contain the other patient, the correct patient, right? So what we saw was that we wanted 0 of confidence, really. Maybe we wanted something else from the confidence, right? Because we wanted the LLM to say, I don't know, right? And maybe we want the confidence to not be how sure you are of your answer, or maybe I wanted the confidence to be something else. For example, it can be saying, I want you to say how confident you are that your response is a good response for my question. And then an example for that would be that if you don't know the answer, return 0. And look, I tried to do it here, right, in general. I said that 0 should be for answer is not supported by context at all. So it didn't get it, right? The LLM doesn't always get us. It's like, think about it like a very, very junior engineer in your team that is not, he studied a lot, right? He has a lot of knowledge in his head, but he hasn't implemented anything yet. So he doesn't know how to connect the dots. And it makes a lot of mistakes, right? So I explained as best as I could, but this explanation probably was not good enough for him. So I would think about improving this, right? What does 0 mean? And also providing another example with 0. Okay, for example. Any more suggestions? What can we do better? Okay, I will give some time in the end to talk about more options to do with better RAG. Okay, so something else that we can do here is we can give more examples, right? We can give 10 examples. It's still a very good context for the length. It will cost us a bit more to run with LLM because the input will be longer, but few more examples can't hurt, right? And we want the examples to really take into account possible scenarios that I have. So this is something I do before coding. I sit down with the manager in charge, with the expert in charge, and I say, what can the queries be? And what to do in each case, right? To build maybe a decision tree for every option. And what I want is my prompt to include all these options with examples, with explanations on how to do it. Okay? The more complex my business case is, the more complex I want the prompt to be. And it will be a bit more complex to check it later. But we have all these tools now. Okay? So, improving the prompt is another option, right? Adding more queries, taking into account more issues is also a good way to check this. We talked about the temperature, right? We should leave it at 0 as I see it. If you think differently, you can try. Okay, this you have the code, you can try everything that you want. You can do it now while we talk, right? And give me some examples of what you tried. Did it work? Did it make it worse? right? What else can we do, right? We can check the code. We can check if really the code here does what we think it does. Maybe we have something that is not correct, right? I mentioned previously that I have the column patient, right? And the column patient, we have a bit of trouble of how to extract it, okay? So if we are not sure from where to get column patient, what is derived from this column is the ground truth for this query, right? That we compare it to, and it affects our evaluation metrics. So we need to think about what to do in cases of ground truth not existing, for example, right? Let's look it up here. So where I mentioned, here is how to get the patient. And then we have the option of the ground truth. So this is the ground truth of the patients. Maybe I want to say a ground truth about other things as well, right? Maybe I want to say one option of the ground truth is, let's say, the flu, last date of the flu. And I register the date in the ground truth, and then if the question mentions the flu and no patient and the flu, then I take this knowledge of the flu. Okay? What else? What else can you think about that will improve the ground truth in order for us to get correct evaluations? Don't be shy. We are here for you to try and think aloud, because this is a playing ground. Okay. So we can add more ground truths. But what else? We can specify how to connect the ground truths with the query, right? Exactly. So someone wrote here in the chat, right now, ground truth doesn't seem to be question specific, right? So we need to make ground truth better. This is something you can play with this notebook. Okay, I want you to try different things. I'll be happy if you try it later and write to me what you tried, how it worked. I'll be very honored to read about it. Okay, so we can improve the actual ground truth text, right? We can make it more inclusive of subjects. We can improve the logic of how the ground truth connects to the query, right? Which ground truth to take. Okay, maybe a few, maybe more than one, right? If it's about patient B and about the flu, maybe I'll take both ground truths, okay? So these are things we can do, okay? We can implement more metrics from RAGAS, okay? If you check RAGAS documentation, you have many more options. They're evolving all the time and they have new ones. These are considered the 4 popular ones. And well, that's it for RAGAS evaluation, okay? What I want to talk to you about, if you have more questions or thoughts, you can write in the chat, but I'll continue with something else that I wanted to give you as a bonus to this workshop. I want to talk to you about general knowledge in the world and how we can use RAG effectively for knowledge. So if we have a long document of the train's engine manual, right? We can put it in text with vector store. It will work really well, this RAG, okay? But there are some possible options for our data that will not work well with this simple RAG. So what happens is that we also have options for more RAG architectures, okay? I'll stop sharing. I want to tell you about it. So RAG architectures, let's see if we can see me in the view. Better. RAG architectures are more options to save all of the data of all of our documents in a way that we will be having an easy time when we want to take out the relevant context. I see a question in chat. I will talk about it soon. Okay, let me finish. So I want to talk to you about two options for RAG architectures that are considered more modern to be used, right? One is graph RAG, okay? And think of it like all your Facebook or all your LinkedIn connections connected together, Instagram, right? Like a social group, how everyone is connected to everyone in relationships. For example, in a family, this is his mother. This is his brother, okay? So all the relationships there, and you can implement this in RAG. You can have all your documents read, put into a graph RAG, right, that remembers all the connections, and then if your type of queries, for them, the connections are relevant, it will be very easy to deduct. Okay, this is something a simple RAG can't do easily. Okay, and another one that is more modern, even more new and innovative, is called structured RAG. Okay, you take all the text, it's text data. Okay, everything is in text, but you imply some logic around it and you create from it tables. This is very good to deduct somewhat an SQL logic on the data for the retrieval of the relevant documents. Okay, for example, if I have some text talking about many cities and what is their score for visitors and how many restaurants they have, things with numbers, then I can create some kind of table for this data, structured RAG, and put everything in rows. For each city, I will have some numbers. Visit to SQL query. So these are two modern options.
Hello, Maya. Is everything okay?
I'm sorry, I was disconnected for some reason.
Can you
Not
hear
sure
us?
if I can see the chat anymore. Yeah, I can see it. Good. Okay, sorry. So the question is not very clear how we evaluated the context recall. In the real world, the set of context documents can be huge, right? And evaluating Cartesian product of queries versus docs might not be feasible. Okay, right. So there are many, many methods to do that. I can't go into everything today. You can write to me in private and I will be happy to talk some more about it with you. Okay, there are methods for that. I was talking like in a general mode, what you should know about what you should know, right? Because if you don't know how to ask the correct questions, as you did here, this is a very good question, then you're a bit blind. And I don't want you to go blind into working with AI. So this is my big takeout. Take with you that you can build things that you can trust. I'm here if you have any more questions. Looking at the chat. Thank you, everyone. Thank you for the kind words.
Thank you, Maya, for the great tutorial. For everybody else, we'll take a short break and be back at 11:45. So until then, see you all. Thank you, Maya, once again.
Thank you, everyone. Please keep in touch. Bye-bye.
Goodbye.